Everybody, it is Mr. R here, and it's Wednesday, December 20th, and this is going to be the last actual class day that we do here before the Christmas or holiday break. And so we're starting here today as advertised. This is going to be the beginning of the weather theory. There are going to be at least 4 40-minute segments on weather theory. There could be more, and it just depends on, how things go. So I'm going to be doing that, and I will have those classes, I will have them posted by Friday evening. So those will be available to you by this Friday. This will be the first one. And so those are going to be your assignment. So whatever video segments there are on weather theory, that is what you're going to be tasked with. So I just wanted you to be aware of that. But we're going to start here, before we get into the weather theory, with real talk. Here's the real talk. My guess is that some of you had a little bit of a rude awakening today coming into the class and getting a pop quiz. A pop quiz on weight and balance, a subject that is critical when it comes to the safe operation of your aircraft. Here's why I did the pop quiz. When we have students electronically knocking out a quiz in less than 5 minutes with a 100%. Oh, what does that tell me? Well, it tells me that you memorized the answers to the questions. Okay? That's what you did. And if you know how to solve the problems, there's nothing wrong with that. But I want to tell you what I told you on the first day of class. What I told you was, I'm probably the only instructor that you're going to have in high school that is going to give you the answers to the final on the first day of class. But with that, there comes a responsibility. The responsibility is this. You can't use this as a crutch, okay? You use this as a ladder. And here's what I mean by this. If you want to memorize this stuff, you can, but that's not its sole purpose. The purpose of this is to help you when we go through the stuff that we have in the books. So your responsibility is reading the material, first of all, in the book. There are questions, there are practice questions that you can answer at the end of the chapters in the books. So you can do that also. The answers are in the back, by the way. You use this to help you with these things that we cover, things that we go over in class. I do videos showing you how to solve sample problems. But guys, if you're not doing the work, if you're leaning on a crutch instead of a ladder, this is kind of what happens. Plus, how many times have I said, am I going to sound like your parents right now? Maybe. How many times have I said to you, email me, text me, if you don't understand something, let me know. I haven't gotten a single question about weight and balance. So, what do I think? Hey, they got this. It's great. It's awesome. But maybe not. Do not use this as a crutch. This is a resource. It's a ladder. It's to help you get to the top. Okay? That's what you need to do. Taking this course, the reason that you can get college credit for this course is because it's hard. Okay? That's part of this, and it requires initiative. There's no spoon feeding. You all know that. I'm not going to do that. That doesn't help you at all, okay? You got to do the work. And if you have a problem doing the work, Tell me about it. Tell me what the issue is. Tell me what's holding you back. And again, remember, the first thing I'm going to ask you is, show me your notes, okay? Show me your work. Show me that you have made effort, and I will crawl through broken glass to get you to the top. But guys, if you're not doing it, tell me what you want me to do. Because me doing it for you is not an option. Okay? Now, please, let that be the last time that I have to explain that. Okay? All right. So, here we go. Now, with that. Oh, by the way, on the quiz, in addition to the weather segments that I'm going to do, I will also do a video segment to walk you through these problems again. Okay? So, look for that video segment for you to go through and to not just see how I do the problems, but to also see what the correct answer is. And I'm still kind of deciding how I want to grade this. Originally, I was thinking that I would do this as just part of your regular grade, to put 7 more points possible there to your total. I may do this as bonus points, okay? So that's what I may do. I haven't decided yet because I haven't seen how hard you worked on it. So that'll be up to you. All right, now, with that little business out of the way, let's get to the weather. Now, in chapter 30, remember, we're skipping the navigation section, and the reason we're skipping the navigation section is because once we start looking at navigation and those instruments, you kind of have to know, why is it that I may not be able to see outside of the cockpit? And so we have to talk about weather, because if we don't talk about weather and we don't talk about how air masses move and fronts and things like this, you're not going to be able to do the flight planning. You're not going to understand why we're doing what we're doing with the navigation. So we're putting the weather ahead of this. Okay, so that's what we're going to do. There's 2 major sections of the weather. One has to do with weather theory, and we'll talk about that. And guys, this is earth science, okay, just so you know. Then the next part is going to be, how do we as pilots take a look at what weather services are available to us so that we can help predict what weather we're going to be flying through. So there's 2 parts, weather theory and then the weather services. So this is kind of it. Now, as we look at the book, the other thing that we're looking at here, and this is one of the things that I think that the actual FAA book kind of does a little bit better in this regard, is that it really does more of the basics up front, because right here at the very beginning, in the very first portion that they put up here in the margins, is that we already start talking about lapse rate. Well, we haven't gotten anywhere near what a lapse rate is, and it kind of starts the weather somewhat abruptly. So with that, I'm going to do this a little bit differently. I'm going to back up and I'm going to show you here some of just the primary conceptual elements of weather. That once you have these, and if you do nothing more than remember these basic elements of weather, where it comes from, kind of how it all works, the pieces will fit together for you better as we go back through this book. So that's what I'm going to do. So with that, I'm going to take you to this little image right here. What is this, you ask? Excellent question. What this is that right up here at the very top, what do we got? El Sol. This is the sun, okay? So that's the sun. It is that bright star out there that kind of illuminates the sky during what we refer to as daytime hours. And then, of course, it's on the opposite side of the planet here during what we refer to as nighttime hours, okay? And also, just as bonus information, FARs, okay, the FARs, definition of nighttime. Anyway, as we look at the weather here, this is what we're going to be starting with. So the sun does what? Well, of course, it gives us illumination, but it also does something else. From this sun, we get these little things that are emitted by the sun. We call them the sun's rays. The sun's rays, this is that part of solar radiation that comes down and it warms our earth. Now we all know, or at least, my Lord, we all should know, seasonally kind of the position of the sun as we kind of, as the earth kind of rotates on its axis and it revolves around the sun, okay? All right, so that's kind of what we do. And seasonally, we also know that that rotation moves a little bit, not the rotation, but also the angle at which the earth sits. And so during the during the summertime in our latitudes, we actually wind up with, number one, more daylight, and two, warmer temperatures. Whereas in the wintertime, for us in our latitudes, we're a little bit angled differently. Days are shorter, and the temperatures are going to be colder, just because of the fact that, we're angled differently, and that's kind of sort of, what happens. So when we think about the function of the sun, is that it warms our planet, it warms our atmosphere, and it allows life to exist. But when that solar radiation hits our Earth, something different happens. So as we look down here, here's a couple of things. So this part here, this is the ocean, okay? So this blue part here is the ocean. Then we have this brown part right here. Let's call that New Mexico. Then we've got this green part over here. It's Kansas, okay? So here's Kansas over here. Here's a wheat field out here. Farmer Smith, he's got his wheat field working out here. Nice and green, looking lovely. Then we have New Mexico, kind of brown. And then we have the ocean, okay? So what happens is this solar radiation, these light rays, they reach the surface of the Earth. Now, when that happens, something else happens. And to explain that, I'm going to ask you this. Okay, here's what I want you to do. I want you, without hitting someone next to you, I want you to stretch your arms out. Okay, stretch your arms out like this. Turn your palms up. Okay, turn your palms up like this. So here you are. Got your palms up here like this. Now I want you to close your eyes. Okay, close your eyes. Okay, so here we are. Now, I want you to pretend with me, close your eyes. You're picking. I want you to pretend it's my birthday, August 15th. It's my birthday, and you're standing in Phoenix, Arizona. You have been in a mall shopping for my birthday present. By the way, I like Tommy Bahama, okay? You're shopping for my birthday present, and you're coming back to the car. Now, you're walking through the parking lot. And as you're walking through the parking lot, one of your friends, well, they call themselves your friend right now, but you're about to find out that they may not be. One of your friends says, "I dare you to touch one of those cars." So, you're standing between a black car over here on your left and a white car over here on your right. Okay? Black car, white car. August 15th, it's 3 p.m. Not a cloud in the sky. Phoenix, Arizona. Which car are you going to touch? Okay, you're going to touch the black one, you're going to touch the white one. Which one are you going to pick? How many of you said white? Why? Correct. the lighter colors in our spectrum, our visible spectrum, tend to reflect some of that light and ergo some of that solar radiation. Whereas the darker colors tend to absorb that radiation, that light, and they tend to get warmer. Okay? So your darker colors are going to be hotter than your lighter colors. Okay? Everybody kind of knows that, right? Okay? Have you ever been to Phoenix, Arizona? You want to know why everybody drives a white car? Well, anyway, this is the deal. Now, hopefully you did not set that Tommy Bahama bag on fire when you set it on the pavement, because that black asphalt gets pretty hot there in Arizona. So hopefully there was no damage done to my birthday present. So with that, you've decided you're going to put your hand on the white car because it's cooler, okay? And that's a relative term down there, by the way, a little bit cooler. But that differential doesn't have to be too much to really reach over there and grab something that's going to kind of burn you, right? Quick side note, I played golf in Phoenix, Arizona, the end of June one year, and we got the discounted round by playing in the afternoon. There came a time that I had to use my golf towel to pull the golf club out of my bag because I couldn't touch the metal on my irons. That's how hot it was. Yeah, so that's kind of why they discount that, and it was kind of stupid for us to be out there, but yeah. So that's kind of the thing here. So now, let's apply that same principle to what we're looking at here. So here we are. We're looking at this. Now, I want you to look at this ocean. What's the color? It's blue. Let's look at New Mexico. What's the color? Brown. Let's look at Kansas. What's the color? Green. If you were going to guess which one of these surfaces was going to absorb the most solar radiation and become a surface temperature to become warmer, which would you choose? Blue, brown, or green? I think most of you have figured out it is New Mexico. So let's think about New Mexico here for just a minute. So here we have this surface. This surface is going to be warmer. When that surface becomes warmer, what happens to the air above it? Those of you that say that the air warms up too, that is correct. That air warms up, and when that air warms up, what happens to the density of that air? When that air warms up, the molecules spread out, they get further, and that air expands. When it expands, it becomes less dense. So through something that we call convection, it is an example of that warm air rising. So we have an example of this warm air rising. Okay, that is called convection, when that warm air begins to rise. Okay? So conversely, compared to that brown ground over here, what do you think is going to happen to the air relative to the brown over the ocean and over Farmer Brown's wheat field? Well, that air is going to be relatively cooler. And notice I said relatively cooler. It's not going to be like super chill. It's just going to be cooler. And so with this, as you know, with that convection, that warm air rises. Conversely, you would also expect the air adjacent to that is going to be cooler. When that is cooler, then the molecules get closer together, they become more dense, and that cool air begins to go downward. Okay? So another thing happens here between these surfaces. You know that two objects of roughly the same type of density cannot occupy the same space. Thank you, Archimedes. Okay? So we know that we have that warm air rising. As that warm air rises, it creates a void. That void has to be filled. And so what do you think is going to fill that void? Well, if you're thinking this is going to happen, where that cooler air could move in and kind of fill that space right here, you would be correct. And remember also what happens to the air as our altitude increases. Remember that in a standard rate, the air temperature decreases approximately 2 degrees Celsius per every 1,000 feet. So we have this warm air rising here, but at some point that warm air is going to cool. Well, what's going to happen when that warm air cools? Well, that warm air is going to occupy this space as it cools that has just been left in a void over here where this cool air is falling. When this part and this part, when that happens, you have air moving from one place to another. Air is moving from one place to another. What do we call that? Yep, that's what we call it. When that air is moving from one place to another, this is where we get wind. This is where the airflow, we start to think about where it all comes from. So that's part of how we get it. So if we think about this, here are two things you need to know from this example right here. First of all, the sun is the source of all weather on our planet. The sun is the source of all weather on our planet. Got that? How does that happen? Because of the uneven heating of the Earth's surface. The uneven heating of the Earth's surface. Number one, those are two of the conceptual basics that we have with regard to weather. The sun's function in all of this, and the fact that we have different colors on our planet. And isn't it an awesome thing? Okay? So that's kind of how it goes. And by the way, it is raining like crazy right now. So I'm hopeful that we don't have any electrical issues here again. But that's kind of how that works. Okay? So those two things, if you know those, you've got a good start to the basics of weather. Now, let's look at one other thing. Something else kind of happens when we have air that rises. We have this convection and we get areas of low pressure. Part of those areas of low pressure, one of the things that happens is as that air rises, it also turns counterclockwise and up. Okay, so that warm air turns counterclockwise and rises. So what you have here is you have this kind of a thing right there, okay, where that warm air begins to rise and circulates counterclockwise. As the cool air falls and that pressure becomes more dense and you get higher pressure, that air actually turns clockwise and comes down. Low pressure, counterclockwise, and up. high pressure, clockwise, and down. Okay? Got that so far? All right. Let's look at that low pressure. If we look at that low pressure, what does that kind of remind you of? Those of you that said a tornado, that is an extreme example of an isolated low pressure system. That's kind of what a tornado does. It spins counterclockwise in our hemisphere. In the northern hemisphere, it'll turn counterclockwise. In the southern hemisphere, it's going to turn clockwise. More on that later. Another example of a huge low pressure system is also going to be a hurricane. So there's another example of a big low pressure system. Okay, again, in our hemisphere, spinning counterclockwise. So keep that in mind. Also realize low pressure normally indicates that you may have, I don't want to say worse, but you may have more poor conditions for flying, whereas in high pressure, normally you have more favorable conditions for flying. So in most cases, the high pressure systems, you have things sort of where we fly are a bit more stable. But when you think about low pressure and how all of that works, they can be a little bit more unstable. So that's kind of the things that we sort of have to think about. And so one of the things that of course we're going to want to know when we're doing our flight planning is to say, where are these pressure systems? Because once I know kind of where these pressure systems are, then I can kind of start determining how I want to make this flight. Or do I even want to try it? So those are some of the things that we think about. Okay, so there we go. My prayer is that you drew this because again, I don't do handouts on this stuff. So with that, this is sort of the basics of kind of how weather works with regard to our sun, the uneven heating of the Earth's surface, and how air moves when it rises and how air moves when it falls. Okay? So those are kind of the basics. So now we're going to switch back over here to the book. As we look at the book, we're going to look here, and again, it talks about wind, air masses, and fronts. It talks about the nature of the atmosphere. In this case, I actually think they could probably call this the nature of nature, because that's sort of how it works. You guys are pretty much aware, or you should be by now, that we have several levels of our atmosphere. One of the things that you're going to need to know is sort of this thing that we call the tropopause here, and our troposphere. So when we look at the troposphere, this is where most weather occurs. Most weather occurs in the troposphere. Most weather occurs in the troposphere. You can get weather higher than that, and it does happen, particularly in kind of stormy summer weather, but it's kind of rare. So if you look at this, the difference here is that above the troposphere we have the stratosphere, and above in that stratosphere, you know, that's in that 41,000 foot range. This is where some of the airliners, they can kind of cruise up there. Certainly the higher flying military jets can be up in the stratosphere. So that's kind of one of the things that you sort of need to know what those layers are. We look at this, and I want you to note this part. We talk about the tropopause. Okay, the tropopause is that layer that is sort of between the troposphere and the stratosphere. It says that it's about 65,000 feet above the equator. And over the poles, it drops down to about 20,000 feet. ¿Por qué? So when we look at this, we think, okay, well, why does that happen? How cold is the air above the poles? Oh, that's right. It's going to be colder. How warm is the air over the equator? Yeah, it's going to be warmer. So what happens is that at the equator, the atmosphere expands, whereas conversely, it sort of contracts at the poles, okay? And again, it has to do with the temperature of that air and its density. So it expands at the equator, contracts here at the poles. So what happens in between? What happens sort of in our latitudes and kind of those mid-latitudes that we have? Well, you kind of have this little sort of a shaving off. You sort of have this incremental curve where that excuse me, that level of like 65,000 feet at the equator starts to drop back down the further north and the further south it gets. So it may be only 35,000 feet sort of in the mid-latitude levels, you know, between the poles, between the poles and the equator. So that's kind of where that is. Now, why do I tell you that? The reason that I tell you that is because, again, remember where most of this weather happens and know what happens during the summer. So in the winter time, that layer here that we're talking about here with the tropopause, it may drop down. It may get lower than 65,000 feet. I'm sorry, it's lower than somewhere in that 37,000 feet that they talk about here. I'm sorry, guys, I'm looking at my phone here as well. It may get lower than 37,000 feet. In the summertime, it may get higher than 37,000 feet. It depends on the season, it depends on the air temperature. Okay, so that's kind of what we're talking about. As we look at this, we talk about these winds. Forgive me. One other thing that I want to show you here, and this is something that they just sort of throw in. We haven't even gotten to the point where we know what this is yet. We look at these things and we look in terms of pressure. So remember that when we look at pressure, we're talking about differences here between lower pressures and higher pressures. You see these numbers over here. You see 1010, 1014, 1018. What is this? What does that even mean? Remember when we talked about what a standard atmosphere was. We said a standard atmosphere is a pressure at sea level of 29.92 inches of mercury. That equates to 1013.2 hectopascals or millibars. That is the international standard. Hectopascals or millibars. When you look at this, how is this expressed? It's expressed in millibars. So do you think you're going to need to maybe convert inches of mercury into millibars at some point? Yep. So you kind of have to know what that is. Now, it says low pressure up here and it says high pressure down here. Don't think that everything here that may be south of 1010 is going to be low pressure, and everything north, I say north, everything above with a pressure reading of greater than 1030 is going to be high. It has to do with the relative pressure. It's just like temperature. You may have, in the summertime, you may have a 3-degree difference between like 85 degrees and 88 degrees. That 3-degree differential may cause a change in atmospheric conditions affecting your weather. And then sometimes it may not, depending upon other atmospheric conditions. So those pressure differences, just like those temperature differences, are all relative. So you kind of have to know that there's not like a set standard that at this number, that's low, because it depends. It depends on what's happening in the atmosphere, what time of year it is, all of those things. So just keep that in mind, okay? So as we look here, this is kind of an example of what we're talking about. So if we see here, now they're defining this pressure gradient here as low as something over here below 994. And we have something high here, something greater than 1030. The reason that this arrow is here, and the reason that you see the differences in the sizes and the thicknesses of these arrows, it has to do with the magnitude. So with this, you have a pressure gradient force between this high pressure and this low pressure. Well, you've only got about 20 hectopascals differences here. So that difference, that differential, is not that great. Whereas when you look here, you have a high pressure here of 1030. Now you go all the way down to 994. Well, that's a big difference. And what happens is that on those big differences, you can expect that air mass to move faster with greater velocity, ergo greater force, than you would of just slight differentials. So on that top example there, you might get a slight change in the air mass, whereas in that bottom one, you're going to get a pronounced change in that air mass. Okay, so just kind of note how that works. Another thing I want to point out briefly is that as these numbers get lower and lower here, indicating a lower pressure, these isobars, these lines that we have, these isobars, they get closer and closer together. We call them tighter. They get tighter, and they, in some cases, when that pressure is really, really low, it just looks like a bullseye right there on the map. So just kind of know that that's sort of how that works there as well. So the winds, we talk about the winds moving from one pressure area to another. That's kind of how we get wind. I have gotten, since we started this recording, I have gotten like 8 different phone calls from all these different states. I just got one from Idaho. I don't know anybody in Idaho. I think somebody has gotten my number because I get these things about, you've just won a cruise to the Bahamas and blah, blah, blah. And I'm thinking, how in heaven's name do they have my phone? So, Coriolis effect. Remember that we talked about this. Let me get back over here to this as well. Okay? Remember that our air kind of rotates around its axis. So our Earth kind of spins. When we think about this, you have to kind of think, okay, if the Earth is rotating this direction, where is the Earth, where is that kind of moving? How does that ultimately force this air to move? We have friction. Okay, we have friction around here. If you've ever stirred like a gallon of paint with those stirrer sticks, and you kind of move that around in a particular direction, and you sort of watch the streamlines about how all of that stuff kind of works, you can kind of see what we're doing. If you've ever seen something that we called a turntable back in the day, where you actually put this vinyl record on a turntable kind of a thing, that's kind of what we're talking about here. I guess clay pots in art class with this. And we think about the Coriolis effect, how that ultimately works here with our air and our atmosphere. We get friction near the Earth that also kind of moves things, but we ultimately wind up with air moving faster the higher that it gets above the Earth. That friction kind of slows air down as it moves primarily from west to east. Kind of slows things down a little bit. But then again, we have that constant moving above the Earth. That constant moving above the Earth with those winds, we get greater wind speeds. We have this thing called a jet stream that we're going to talk about here also that kind of moves around. But part of that has to do with the Coriolis effect. So when you read this, you'll see kind of how that works. And again, that Coriolis effect acts toward the right in the northern hemisphere. So in the southern hemisphere, you might expect it to go to the left, okay? So this is kind of how this works. If you have low pressure up here, that airflow, because of the Earth's rotation, is going to kind of be up and to the right. And when we have high pressure to low, down here kind of toward the equator, that air is going to move this way, but it's also going to start moving to the right, okay? So that's something that you will be asked about the Coriolis effect. Now, I want you to look at figure 30-3. Remember what I said about high pressure. Air flows in a clockwise manner around high pressure. it flows counterclockwise in low pressure. Now, I want you to think about this for just a second and think, okay, here I am, I'm super pilot, and I'm thinking, okay, what's going to be my best route to fly around something here if, let's say, that I'm right here? Do I want to fly around this? Do I want to try to fly over that? What's going to be my best play? Well, let's think about this. If you fly down here, remember this rotation is going to be here. You may wind up with a headwind. What's the rotation up here? Counterclockwise. You may wind up with a headwind. But what's going to happen if I try to split the difference between a low air system or a low air pressure system above me and a high pressure system below me? Well, I may be able to take advantage of a nice little tailwind right here. Again, providing that the turbulence is down or whatever. And if I'm thinking, okay, Mr. R said that flying in a high pressure system can sometimes be better weather than low pressure system, then instead of splitting the middle right here, what I might want to do is perhaps edge a little bit further out here on this high pressure system to stay in a little better weather. I may sacrifice a little bit of a tailwind, but my ride may be smoother. So that's one of the things that I think about here when we look at navigating between these pressure systems. Now, conversely, if I am thinking, okay, I'm over here and I want to get here, let's say, what's going to be my best play? Well, if I come around here, I can maybe take advantage of a tailwind. But I also know that flying here, especially in the northeastern quadrant of a low pressure system, I may wind up in some bad weather that we're going to talk about here in just a minute. So Mr. R said that if I fly near this high pressure system, that may be the best play for me. So in this case, what I might be tempted to do is to come down here and to fly just to the south of that high pressure, come in here, and then be able to ultimately take advantage of a tailwind and kind of maybe make that go. Again, there's a lot of variables in there, but this is one way that we kind of just overall start looking at those pressure systems. Okay? Here's this. All right. And we talk about this also that we've talked about wind shear. What is wind shear? Well, as they say right here, this is kind of what wind shear actually is. Wind shear is that variation in speed and or direction from one place to another, and it normally happens between a cold front and a warm front, or a warm front and a cold front, where these fronts, what's a front? We haven't talked about that yet, but we're gonna. Where these kind of come in, and this is where we get wind shear. Where's another place that we could get wind shear? What's that? Aspen? Yeah. The mountains, you think? Think about that wind coming over those mountains. And when it comes over those mountains, weather in a blender. That's where we can also get wind shear. Wind shear can occur anytime, any place, any direction, with or without warning. We know that there are certain places where we can sort of expect to have wind shear. When we're flying through a temperature inversion off the ground, when we're flying in the mountains, when the winds are greater than 30 knots coming over those ridges, when we're flying around a thunderstorm, we can expect wind shear. When we're trying to land somewhere and there may be a thunderstorm somewhere in the distance, some part of that airport, we can expect wind shear there as well. Wind shear is one of those things, guys, that there are certain areas of predictability where you can expect that to happen more than others, but there's no guarantee. Clear air turbulence can also happen. Clear air wind shear. You never know. Something's going to happen. The old adage, you know, a butterfly flaps his wings in Peking and it rains in London. There's always these other little things atmospherically that we just can't predict. This is why we wear seat belts in the airplanes. It's why we kind of snug those up, even when we're having that magic carpet ride. Because I have flown in conditions where it was just like, oh my gosh, this is so amazing. It's so smooth. It's, oh my gosh, you know, and the next thing you know, you're bounced around the cabin. Where'd that come from? Yeah. So, this is something that you need to understand about wind shear. Now, one of the things that we talked about is that in that early illustration, it was something here, and this is something that we talk about here where I'm trying to find it. I just saw it here, a sea breeze or a land breeze. If you remember that illustration here, can you kind of predict where you might wind up with let me find my color, with a sea breeze here, and where you might wind up with a land breeze? Let's think about this. What happens when El Sol goes to bed? What happens to the temperatures of those surfaces now? New Mexico gives up that heat quickly. There's nothing to hold it. So now New Mexico becomes cooler than Farmer Jones's or Farmer Smith's, I forget which guy was farming this, wheat field in Kansas, and the ocean. Those temperatures will stay a bit more stable. So when that happens, this whole thing that I have drawn here goes backwards. Well, when that happens and that sea is warmer than New Mexico, that current turns around and it moves this direction. And this is where you would get that land breeze, and this is where you would get that sea breeze, okay? It's just kind of when those things happen. Where would you expect that to happen? Well, probably not the Pacific Ocean in New Mexico, at least not until California falls out into the Pacific. But it is going to be in coastal areas that you kind of might expect that to happen. The Great Lakes, possibly, although the Great Lakes, that's kind of, you talk about weird weather. The Great Lakes has some pretty crazy weather up there. So I just wanted to share that with you, kind of like what we're talking about here with this stuff. So as we look here, let's take a look here. So figure 30-5, we think about this thing and we think about where do you think you might get this kind of wind shear? Well, if you look at what they have drawn here, is that this is kind of an area, I'm trying to get my pen working here, come on baby. Here, where you've got wind moving this direction here, you've got wind moving this direction here, and let's say that you're trying to land here and you're flying this direction, okay? What might happen with those winds? Well, you might expect during the day that you're going to wind up with a headwind here, but that wind could turn around here on short final or final, and making that you landing with a tailwind. So you may have to rethink your strategy. Let's think about this example. Okay, so here you are, here's your little airport right over here. This is kind of where you want to come down and land. Or do you? Because in this area right here, if this thing indicates with a cumulonimbus cloud that you have these strong downdrafts, you probably don't want to land this direction, do you? So you're probably going to want to know what stage is this cloud or storm or whatever that may be. What is that? And you may want to approach from this direction, okay? So these are things that you're going to have to know. Another thing here is I talked about that temperature inversion. This kind of happens. Denver used to be notorious for these temperature inversions, because if you look at the way Denver sits, it kind of sits in a bowl to the west, to the east of the Rocky Mountains there, and then where the plains start to rise as you start moving out into eastern Colorado and into Kansas and Nebraska. So those plains, the high plains, they kind of, there's this area, this big bowl that Denver sits in. And you can have these temperature inversions where, you know, instead of, you know, of having the air, you know, kind of the way that temperatures the way that you think you might normally have them, where they get colder as you go up, you may have warmer air trapping colder air, colder air trapping warmer air, goodness, here in this area. And then as you're trying to fly through this zone, you may have weather moving any direction. So you always have to be careful anytime that you're flying through an area where a temperature inversion exists or is forecast, okay? So there's part of that. Now, I think I have maybe overextended my time for this particular broadcast here. So anyway, guys, again, I will be recording the rest of these videos so that you guys will have them, okay? And I'll have them on here by sometime Friday evening is when I'll have the other videos where we go through the weather theory part of this. That is your assignment for the Christmas break. Because when we come back, we're going to do one class of a review, and then we're going to test on weather theory. And then we're going to get right into the weather services, okay? So that's kind of what we're going to do. Guys, enjoy your break. I hope that you have safe and happy holidays, and I just can't wait to get back together with you when I come back the beginning of January. Guys, be safe. I miss you, and I will talk to you guys soon. See you guys.